Hey everyone, thank you so much for joining today's workshop. I'm super excited to have you all over here. If you're new to my workshop or events, I just want to introduce myself. My name is Rashmi Krishnamohan. I work as a senior data analyst at a local non-profit organization here in Windsor, Essex. So I'll be guiding you through a hands-on machine learning session today. It'll be like a very beginner-friendly session, and as you can see on my screen, it's going to be like a customer churn prediction model. So you don't need to be an ML expert, just need some curiosity and like a basic Python skill is enough. So today's session is all about learning by doing. So I highly encourage you to like try to code along with me. And since it's only a 2 hour session, we are trying to jam pack a lot of things that I'm planning to do today. So I'm just going to get started. Like I don't have access to the chat. If you have any questions, please like feel free to unmute and or raise your hand. Anything works. Or if I'm going too fast or you want me to explain it again, yeah, feel free to like unmute and let me know. I'll try to go a little bit slow, but since we have a lot to cover, I'll try to like pace up a little bit. Okay, so we're going to, as you can see on my screen, I just want to say, show like what we are going to work through today, like the flow chart, like end to end, what we can do in this limited hard, like 2 hours that is allocated for this event. One second. So we're going to build like a predictive model that tells us which customers are likely to churn, like meaning which customers are likely to stop using a service. And this is a very common business problem that companies face, especially in telecom industry or banking or even like software as a service companies like Spotify, something like that. So yeah, as you can see, that's the problem statement that we're going to deal with, and we're going to collect data. It's going to be a simple telecom data from Kaggle that we're going to download and use today. And we're going to do some basic data pre-processing in Pandas or NumPy if something comes up, and we're going to treat null values and do some data visualization, basic exploratory data analysis in Python. And then we're going to choose the model based on cross-validation score. And then from that, the best score that we are going to get, we're going to train that model. And I don't think parameters tuning is possible today in this timeline. So I'm going to encourage you to do like take it home, like maybe do like hyperparameter tuning if you're interested. We're just going to deal with our default parameters. So we're going to train a model, and then we're going to like get some accuracy scores and do some classification report, just some comparison. That's it. We're not going to go deep into deployment because that's like not a beginner friendly topic that I want to cover today. But if you are interested, if you want to like keep this going on, I am more than happy to work on the deployment phase of the same project. And the goal of this particular workshop is to help anyone like beginner friendly in ML trying to build like a portfolio project. So this is for you, and you can actually like load that to your GitHub repository and maybe even put it on your resume. So that's the goal of today's workshop. Okay. So what we'll do today is first we'll go to Kaggle and get our um, data set. So one thing is you need like Jupyter notebooks in order to work along with me, or you can use a Google Colab. I highly encourage Google Colab because you don't need any libraries pre-installed. It comes with the libraries pre-installed in Google Colab itself, and it's free for everyone to use. So I highly encourage to use that. But if you have Jupyter notebooks already installed with all the libraries we are going to work with today, please feel free to use that, or else just use pip install, and whatever library is not installed in yours, you can actually do that. I'm going to paste this link in the chat box if you're interested. I'm just going to put that over here. Okay, I already have a notebook created, so I'm not going to open one more. So we're going to, as I mentioned, we're going to do customer churn. So I'm going to type customer churn prediction Kaggle, and the first link that's going to come up, I'm going to select that the telco customer churn. Paste the link again in the chat box. And we're just going to download the CSV file from Kaggle, and then we're just going to see what all columns we are going to deal with today. So as you can see, we are having the telco customer service. So we are having like multiple like categorized columns like gender, senior citizen, partner, etc. So we're just going to download it and upload it to our Google Colab. We have it downloaded. So what I'm going to do here is you are going to go to the files on the Google Colab if you're using over there. If you're using Jupyter Notebooks, you can upload it to the notebook folder. And what I'm going to do is I'm going to upload the file from here. The CSV file. Okay, that's all right. So first of all, I'm going to see, okay, it's connected already. So what I'm going to do is I'm going to import all the libraries or dependencies that I want for this particular project. So I'm going to import pandas as PD, import. All right. So these are like very basic things that you want to have in hand. Even though I'm not sure if you're going to use like NumPy for this particular project, but I just always try to import it whether I use it or not. And then I'm going to use like sklearn libraries today. I'm going to import everything now, and then I'm going to explain why I'm importing this. So first, we are going to import like a label encoder because um, machines can be trained only with the numerical data. Machines don't understand any characters or words. So in order for us to, encode anything as a label, make it like a numerical pattern, then we need to use label encoder. It's an algorithm already written in Python. It's very handy. You just need to like have like a proper syntax, and it's all good. The Python is going to do all the work for you. And that's why I love working with label encoder and not the one hot encoder, which is like even more, it makes the data set very big like including a lot of columns for each labels. And I don't encourage working with one hot encoder, so that's why I'm going with this. And from IMB Learn, I'm going to import something called oversampling. Um, I'm going to import something called as mode. This is used to, address any imbalance in the target variables so that you don't have any bias of majority class and target variables so that the model gets trained equally for both like churn and non-churn. So that's why we are going to do something called mode in this particular workshop today. And I'm going to go more in depth about that in the later part of this session. But next, I'm going to do model selection, and I'm going to import the train test split. And this is how we are going to like split the data into trained data and the testing data. And from the same library, I'm going to do something called cross-val score. And Now I'm going to import all the models that I'm going to use for this particular project. I'm going to go with the tree-based model. You can go with linear models if you're interested as well, but just in case, like I'm just like more in like interested to use tree-based models for this customer churn. So I'm going to import those. So sklearn dot. So first tree-based model I'm going to do is a decision tree classifier. So I'm going to import that from tree. Shinji classifier. And one more model is I'm going to do random forest. So it's going to come from ensemble. So it's part of ensemble's library. So I'm going to do random forest classifier. But if you're interested, you can also do linear or logistic regression or even like support vector mission. And one more tree-based model, I'm going to go with three models today. One more is XGBoost. So I'm going to import that from XGBoost library. Right. XGB classifier. Okay. And lastly, as I mentioned, we are going to look at accuracy score, confusion matrix, and then classification report. So from the sklearn's metric library, I'm going to import all three: accuracy score, classification report, and confusion matrix. I don't want to get into pickle file because it's very complex for today's scope. So I'm just going to go with these for now. Okay, I'm just going to press on enter. And now that we already have the data set in my Google Colab, I'm just going to start creating the data frame by using pandas read CSV mode. So I'm going to do that. If you have any questions so far, please let me know. All right. So first step is I'm going to do this. I'm going to say data loading, and we're going to understand what data we are going to work with, right? So what I'm going to do is I'm going to one second. I'm going to get the link that I uploaded. I'm going to click on this three button. I'm going to click on copy path, and I'm going to paste it over here, right? So it's going to be inside codes, and I'm going to do pf.head just to see what we are working with. Okay, so we are working with customer IDs, like all these parameters. As you can see, a lot of these parameters are actually categorical, and only tenure and monthly charges and total charges seems to be of numerical data type. But I can get this info easily using df.info. And as you can see, as I mentioned, even the senior citizen, even though it says it's an integer, as you can see, it has like 0 and 1. I can also like take a look at that in my Kaggle metadata dictionary that is already posted. It has like what each column represents, it has a definition under that. So it's easier for us to get like a business understanding of what they are giving, what data we have, and what we can work with. One second. So, what we can till that loads, we can just look at the data set. It's that's about the telecom industry data, right? So this customer ID, whether they are a senior citizen or not, 0 means no and 1 means yes. If they have a partner or not, yes or no. It's all categorical. So we can look at those kind of data, if they have dependents or not, if they have any children or parents enroll along with them in this particular service. And this tenure is actually like a number of months each this particular customer has been using this particular service. So this tenure is actually dependent on like this total charges is dependent on monthly charges and a tenure. So you can see here monthly charges 29.85 and they have used for 1 month. And so that 29.85 into 1 is total charges and 56.95 and they've used for 34 months and that's why it's 1889.5. So these three are correlated. So that's one thing that we have to look at when we are doing some EDAs on this numerical columns. Other than that, even though the monthly charges is float 64, the total charges I don't think is of the right data type, and we have to fix that um, during the pre-processing of this data. So it's gotta be float 64. So we have to start working on those. So these are like basic understanding of what data we are working with, right? So this is what, okay. Now, what I can see is the customer ID column is not needed. We don't want that for this ML training session. We're not going to bother with that. So I'm going to start with dropping that particular column. So I'm going to do df.drop. Is this visible? I'm not able to. Okay. Okay. I'm going to drop this particular column. So df.drop. So I can drop multiple columns by using this array list, right? But I'm not going to remove anything else other than this. And the syntax for this is customer like df.drop of column name, and then I have to give an access. Access equal to 1 means we have to drop the column. Access equal to 0 means we are like removing a record or a row. We are going with access equal to 1 because we don't want that column anymore. And I'm going to use something called in place equal to true because we are going to make this change in the df data frame directly. And that's why. Let's see. So now that the customer ID column is gone, I don't see a problem with the other columns. So I'm just going to move on to the next one. So I want to see all the columns as a list just to see what we are working with. And I want to see like all the categories under each column. And to do that, we can use actually something called unique operator. So for example, just to give an example for that, like for senior citizen, right? DF for senior citizen dot unique is going to give me 0 and 1, obviously. So these are like as I mentioned, it's a categorical column, even though the data type is int. That's okay. But if I want to see it all for all the columns here, I want to like make it easier if this is a very like a small data set that we downloaded from Kaggle. But if we are working with a real world raw data, it's going to have like hundreds of column, and you can't just do it like doing like a unique operator for each and every column. And for that, I would highly encourage doing like a for loop, right? For column in df.columns, right? I'm going to do if print the column name, and I'm going to do the same df of column dot unique operator. And this is going to give me the unique categories under each column. And just to improve the readability, I'm going to like print like a star 50 times so that we'll be able to, oops, have a better, clear understanding. So what this code does is it's going to loop through all the index in this particular df.columns, and it's going to return the unique value. Let's see how this looks. Oh, my bad.
Can you hear me? Hello?
Yeah.
Hi. Yeah, my name is Thiago. I'm trying to follow up with you here. I kind of lost after you said that you were doing the drop with the customer ID. Can you show what the prompt was again?
Oh, yeah, yeah, sure. So
Thank
the
you.
syntax is df.drop of, you can either use like this bracket for an array. You can have like multiple columns over there. I just have customer ID. That's okay if you want to use it or not. And then access equal to 1 means you're going to remove a column. That's what you're going to instruct the Python to do. If you're giving access equal to 0, then it's a row. It's not, we don't want to remove any rows over here. It's going to be a column. And that's why I given access equal to 1. And in place equal to true because if we don't give in place equal to true, we have to assign this particular function to another variable, which I don't want to do. You can give like df new and remove this, and this particular new data set would be created, new data frame would be created, which I don't want to do right now. I don't want to drop the customer ID from the df itself. That's why I have given in place equal to true. Uh,
Okay, I see. So I don't know if am I holding you back here, but I'm getting an error saying that the customer ID is not found in the access.
can you check if the spelling is correct or you have any space, leading or trailing spaces?
Um, Seems to be right. Def dot drop open customer ID access one in place equals to true.
Mm.
Uh, could it be that we need the df dot info first? I don't think so.
Can you post copy paste your code in the chat box so that I can look? Uh,
Yes.
mhm.
Uh, Sorry, this is my first time doing the workshop. I'm not
Yeah,
sure
yeah,
if
that's
this is the
okay.
way
No
to go
worries.
through, but I appreciate you just helping out.
Of course, anytime.
Oh, I can't send
No problem, Pablo.
the picture.
Or you can also use one more. You can do like columns equal to customer ID and even like remove the access equal to one. See if that works. Because you're already giving it as a column. You don't need to give access again. So if you want, you can use this syntax if that helps.
Customer ID in place.
Or column equal to, I'm not sure. It might be column equal to as well. Yeah, columns equal to, yeah.
So columns equals to brackets of the customer ID, right?
Mm-hmm.
Oh, there's no access. No. Okay.
Yeah, that's because you're already giving it
Yes.
columns, right? So you don't have to give it
If
again as access.
customer ID in place equal true. It's, it says that customer ID is not found in the access. This is just so weird.
Um,
I have my
I
customer ID as being the first column of the data set.
yeah, yeah. So did you see that in df.info, did you like see the correct column name? Like you have to use the exact name. You can't use like capital letters in between. It's very case sensitive. Python's case sensitive. You can't. Um,
So yeah, when I do df dot oh yes, when I do df dot info, it goes directly to gender. There is not
oh,
even
that
a
means it
customer
worked.
ID.
That means the code already worked. You don't have customer ID anymore. It's deleted. One of your code actually worked. That's what it means. So now if I do a df.info again, I won't have um my first column would be gender as well. This is what you're getting as well.
Yes.
So that means, yeah, it worked. That's good, right?
Correct. I understand what you're saying. It's just that when I try to run the df.drop customer ID in place equal to true, I get a key error saying the customer ID is not found in access.
That's
So
because I think you have like executed the same code twice. Since it's already been deleted, it won't be there anymore. If I run my query again, I'm going to get the same error. Got it? So if I do this, I'm going to get the same error because my customer ID is not found in my access.
oh, there it is. Okay, sorry.
Yes.
I
Yeah, that's
completely missed
okay
that
because it's
part.
already been deleted. Your code already worked. So that's why it won't allow you to rerun the code.
Okay, that makes sense. Thank you.
Yeah, no worries.
Sorry for interrupting.
That's okay. Yeah, ask questions anytime that you feel like I'm going too fast.
No,
Um,
it's going okay. Yeah, I appreciate that.
okay, great. So after the dropping of column, like customer ID column, right? What I did was I did the senior citizen unique operator on this particular column to see what are all the unique values present in that column. So I use this, but it's not possible to use this for each and every column. If you're working in a real world data, it will have like 100 more columns or 100,000 columns, so you can't work with this. So that's why I used a for loop. So df.columns is going to return you like a list, right? So I'm going to loop through that list and I'm going to print the column name and the unique value of the column name. And this is just for readability. As you can see down here, it's just like giving you like 50 times of this particular subtract symbol. So this way you can actually easily get to know what are all the values that you're working with and if there are any errors or something like the spelling mistakes or like this is like something that you could have a quick look at the data that you're working with. But as you can see, the tenure, monthly charges, and total charges are all numerical values, numerical categories, which I'm not interested in looking at, but that's okay. But the total charges has the quotation marks, which means that it's an object, it's not a float. And that's our next step. We have to fix this. We have to make this as a float integer, float type, right? So that's what I'm going to do right now. What I'm going to do is df of total charges.
Before you continue, can you check the senior citizen unique again? What is the after the for loop when we print column for? Can you explain the times 50 there again?
Oh, it's just for this one, just for readability, I included that. Just to have like it will print the sign 50 times, this value, all this. It's just for readability, like it's more clear to read right now, right? That's why if I don't do this, it's going to be one below the
You,
other. That's why I,
yeah. Okay, got it. Thank
yeah,
you.
no worries. Um, so as I mentioned, I'm going to change the data type of the total charges for that. df of total charges equal to df of total charges dot as type. That's the syntax, right? So I'm going to give a float, but I am sure it's going to throw an error. I'll tell you why. It's going to give you the error itself. Okay, 1 second. See, you can see that there are like some null values in this particular column, and that is preventing us to change the data type from object or characters or string to float type. So we want to see why we have like null columns, even though the df.info tells you that there are no null values. It's because the space is treated as a non-null value. It has some value, that's a space, and that's why Python thinks it's a non-null value. That's why we need to change it to a proper data type and then see why it's showing null. Okay. So for that, what I'm going to do here is I'm going to find where this null value is present. So for that, right, df of total charges equal to null. This is the syntax. So this searches for null values and I'm putting that inside a data frame again in order for me to get like this table-like view, like this view. And that's the syntax for us to do find where are the null values present. Okay. So this actually returns all the values that are having null. See, as you can see here, but you cannot just go ahead and drop these nulls because this null is actually significant. It has a meaning why it is null. Because if you see the tenure column, it has 0. That means the customer has actually recently joined this service. They might have joined this morning or like last night or something like that. And they have not finished one tenure, then that's why 52.55 into 0 is null. Like it's 0 actually. Instead of 0, it was null, and that's why it's showing that. So we cannot go ahead and drop it. Instead, we can replace the null values with 0, right? So that we can do. So for that, what we have to do here is I'm going to take the total charges one more time. Okay. And I'm going to do a replace function. Okay. There is something. So I'm going to do dot replace. Okay. So what I'm going to replace the old, it shows the syntax over here as you type. Old, what you have is space and comma. In place of old, we are going to replace it with zero. Oh, I missed. All right, I missed the bracket over here. My bad. So df for total charges dot replace old value with no new value. All right. So I'm going to check my df one more time to see. Oh, I'm going to see if this null value exists or not. Again, just to have a quick verification, right? So we don't have any null values anymore. So it's good. All right, now we are able to change the data type to float. This error won't come one like again. So it's going to change my data type to float. I'm going to copy paste my code one more time and I'm going to do df.info to see if my changes have been reflected. As you can see, total charges is now float 64. Why float 64? We didn't mention 64 here. It's the default data type of pandas. So that's why it's float 64. Whereas in PyTorch, it'll always be float 32. So this is just uh, some ways to like, uh, you know, do some cleaning or pre-processing before you start working with the data itself. Do some EDA, whatever. So next step is we have to check the target column. The target column here is the churn column. So this is what we are going to predict, right? We are going to predict in the future. We are going to train the model. We are going to predict based on all these categories if their customer is going to churn or not. The churn, no means they did not churn. They are still using the service. Yes means they are not with the service anymore, right? So I'm just going to do something called value counts. This is like very handy. Value counts is something that you can quickly do without using any group by function in Python. It is a very handy function to write. So I'm going to do like df of churn, right? Dot value counts. That's it. So what it does is it will tell you how many no and how many yes values are there in the data set. As you can see, the data is very biased. It has a lot of no values, like when compared to yes. And this is not going to be an ideal situation when you're training a model because the model will be biased with the churn, no churn data more than the yes churn. And that's why we are going to use something called smooth, right? The one I mentioned above, the smooth. So you're going to um deal with this, imbalance between two variables in the target column. That's what we are going to do in the future, like in later in the process. So far what we have done is we have removed the customer ID column. We don't have any missing data set, missing values in the data set. And the total charges column had zero that we replaced, the null had that we replaced with zero. And then we have found that there is a class imbalance in the target variable, right? These are all the insights or key takeaways from the data set. Do you have any questions? Because we are going to move on to the exploratory data analysis. Okay. Uh, all
No,
right.
it's all good.
Perfect. Okay, so we are going to do like EDA, right? So for EDA, you're going to do first thing that I always do to get like an insight into my data is describe df.describe. It actually gives you like a quick numerical snapshot of all the numerical columns in the data set. As you know, these four are the numerical columns, even though this is considered as a categorical column. Its data type is in, that's why it's being included in the describe function. And it's always 0 to 1, right? 0 means no citizens, senior citizens, 1 means yes. And as you can see, 0.16 is the mean. That means it's leaning more towards 0. So that means they are like more. like no, not much senior citizens. That's what it's meaning. And these all give you like mean, standard deviation, min, max, like a quick snapshot of what we are dealing with on the numerical side. Okay, let's do a quick numerical analysis, right? Okay. So we are going to do like a quick normal, like a histogram plot to determine the distribution of the numerical features. And for that, I'm going to write a function. Um, since we are having like three different numerical columns, the real world data set might have many more. And you can't just write the histogram plot one more time, like again and again, three times. So for that, we can just write it once and reuse it like as many number of times as we need. So for defining a function, you're going to do define plot histogram, right? And we are going to give two parameters, the data frame itself and then the column name. Okay. And over here, I'm going to give like a figure size just to have some kind of customization. I want to show my figure size in a particular fixed size. So that for that plt.figure of fixed size, it's a tuple. So you have to give it like a comma 4 or something like that. And we're going to use Seaborn's histogram plot. So SNS is the alias name we have, sns.hist plot, right? And the syntax is the df.column, df of column name, okay? And KDE must be equal to true. KDE is a kernel density estimator, something like that. So instead of having all the bars, we are trying to get a curve, smooth curve along with the bars of the histogram so that it's easier for us to visualize the plot. And I'm going to do, oops, sorry. I'm going to give a title, and for that, it's going to be distribution of column name. So when you use this F before the quotes, you can use this curly braces to give a dynamic column name. Whatever column name you're going to use when you call the function is going to come over here. So distribution of tenure, distribution of monthly charges. So it's very easy. Okay. And one more thing is in the histogram plot, we need to show mean and standard deviation, right? So for that, what I'm going to do is I'm going to calculate the mean right now. So columns mean equal to the column name dot mean. That's a very simple syntax. That's it. And column dot median is df of column name dot median, right? So I'm going to show these two values in my histogram plot. And for that, it's a simple syntax over here. I have something. Yeah, I do have my GitHub link. I'm planning to share it at the end of the session. I have it with all the pickle file and everything that you can actually reuse when you're building your model yourself. Okay. So PLT is the matplotlibs library. So AXV line, right? I'm going to call the mean over here. I'm going to give the color red and the line style. I'm going to give double dash for this. And obviously I want to give a label to differentiate between mean and my median. And I'm going to do the same for my, oh, my bad, column dot, it's underscore. Okay, I'm going to do median over here, but I'm going to give the color green or something. And for this, I gave double dash, but for this, I want to give single dash. And this is going to be median, right? And for the label to actually work, you have to call plt.legend, and that's where the label would be displayed. And then PLT dot show, obviously. Now that we have defined this function, you don't have to write this again and again for all the columns, right? And you can just, you can just call this function, and it's going to expect two parameters, data frame itself and then the column name. I'm going to give tenure as my column name first, and I'm going to do the same for the others. As you can see, it's a bit skewed on the right and the left side, and we have the mean and median over here. It's not a normal distribution. It's not Gaussian curve. So I'm going to do the same for monthly charges and total charges. That's it. This is very simple and reusable code. Again, it's not a normal distribution. It's slightly skewed on the right side. And then I have total charges.
Can you go back to your plot code again just
Yeah,
for a
yeah,
second?
yes. I have pasted my code in the chat box if you want to refer to it. So this is what the histogram plot tells you. So none of the numerical factors or columns are having any Gaussian distribution. That's like the bell curve. The bell curve is like mean should be equal to 0 and standard deviation should be equal to 1. So in that case, you cannot use a linear model directly in the state data frame. You have to do some scaling, and you have to do some, uh, standardization protocol in order to make it a Gaussian curve, or else you won't have any like much performance in your machine learning model. But the tree-based models that I'm using in this particular workshop, that is like Bayesian tree, random forest, they don't care about this. They're not sensitive to the Gaussian curve, and that's the reason we are going with um, the tree-based models for this particular workshop, right? And I actually wrote a similar code
Um,
um,
just one
for,
second,
yeah.
please. Trying to run the graphs, but they're not running with your code. Is
Um,
there anything else that I need to add as a library, for example, at the
no,
beginning
actually,
or
you
work?
have you like given the tenure everything in double quotes? I mean quotes. You should be in quotes or else it won't work.
Yeah, in quotes, yes.
It is.
Yes.
So did you what error are you getting?
It's not an error. It just doesn't plot the plot.
Are you giving this within the definition?
Yeah.
It should be, no, the definition is separate, and
Hmm.
then you're calling the function. The function ends,
Yes,
running the code, and in
correct.
the next cell you have to run this. If you're running within the definition, it's a part of the code, and you have to call, like it won't work. It'll be like a loop. It won't work. This should be a separate cell, and this should be in a separate cell. Then it'll work.
Oh, I see what you're saying.
Mhm.
Okay, perfect. Thank you very much.
Yeah, no worries. Is it working now?
Yes, it is. Thank you.
Okay, no worries. So it's a very similar code I wrote for box plot. So main reason we use box plot is to identify any outliers, right? And again, tree-based models don't care about outliers. It's not sensitive, so it is like very redundant. So for linear model, you have to either drop these outliers or replace it with a mean or median. But for this, we don't have to worry about it. And I don't think there are any outliers in my data set as well. So it's okay. So same thing. Instead of his plot, it's going to be box plot. And I gave Y because it can either be X axis or Y axis. It can be both, but for just the plot to look nicer, I gave Y axis, so it'll be like vertical, not horizontal. And I'm going to paste this code again in the chat box so that you can use it just to save some time. Uh, but if you have any doubt in this code, you can ask me now, and I'm happy to answer or to show how it works. But it's just a very simple swap I did. Instead of hist plot, I use box plot, and I changed the parameter like to df of column, and that's only one parameter for box plot. So if I run this function, and in the next code, I'm calling the function again, right? Again, it's going to be same data frame, and I'm going to give tenure, right? So I'm going to do the same for monthly charges. Oh, I have the wrong. And then I have the same for total charges, right?
May I ask you something?
Yeah.
On your definition for the plot histogram,
Yeah.
do you have to have a like a closed statement for the definition of the histogram or no?
No, no. You don't have to have any close statement. The close statement, like you're just giving parameters, right? So you're going to have to call the parameter. So it's going to be passed over here. This df is going to be passed over here.
Correct.
This tenure is going to be passed over here. And it's all going to plot. That's it. It's not returning any value. These are all return statements, right?
So if that's the case, do you would you have an idea why the plot would just keep looping and then creating more graphs?
That's because, oh, is it happening to you? It's because I think you have this in your definition again. You have to remove that line.
No, it's in another statement
Can
case.
you check your definition? Because when you said you're having this within the definition, it will
Okay,
loop for sure. That's what I was mentioning before as well.
I see. Okay.
You have to the last line of this code should be plt.show. That's it. You have to delete the next line that you have,
Yes.
and now it'll work for sure. Now run the definition, the function definition, and then run the function call, and then it should work without issue.
Perfect. Thank you very much.
Yeah, no worries. Um, if you can do the same for box plot in your own free time, you can do that. But as you can see, there are no outliers. How the outliers looks like in the box plot is, okay, one second. Yeah, this is the image. So all these diamonds on top of the box plot are all outliers, and you don't have anything. My box plot does not show any diamonds on top, right? And that means we don't have any outliers. So we don't have to do worry about anything. But if you do have outliers and you're using any linear model like linear regression or logistic regression, you have to address that. You have to remove the outliers or you have to replace it with median or mean. So since I don't have anything, I'm not going to worry about it. Okay. And next is let's go into categorical feature analysis. So far, what we have done is we only worked with all the numerical data, right? Numerical columns, but we are we still have to analyze all the categorical columns like gender, senior citizen, everything. So for that, I'm going to so these are the columns that I'm working with, but the tenure, monthly charges, and total charges are not my new like categorical columns, and for that there is something called as df dot select d types. What it does is it will select the D type, okay? And then we are going to filter only object. We're not going to get any float or integer. So all the objects are going to give us a categorical columns only, and we are going to make it to a list so that we can loop through the list and then, plot once. We can just use one code to plot all the categorical columns. And that's what we are going to do today. And I'm going to do like object list equal to df.select dtypes. I'm going to include only the objects, right? So I'm going to copy that, make sure there are no spaces. And I'm going to use this function called columns to list, columns dot to list. I'm going to paste the code again in the chat box. But if you have any questions on the logic of the code, let me know. But it's just going to filter only the object data type and then make those columns into a list. So let us view what this list looks like. See, it did not include tenure, it did not include monthly charges or total charges. It has only the categorical columns, no numerical columns over here. But as you know, senior citizen, even though it's an integer data type, I want it in my list because it's a categorical column. Right? So I'm going to append senior citizen to my object list. So for that, all you have to do is add the senior citizen to the object list. That's it. And then assign it to the object list again, right? So in my array, so if you want to append more than one, you can just put comma column 2, comma column 3, but I don't have that many columns. I'm just going to do the senior citizen. All right. Now, when I look at the object list, my senior citizen is going to be appended, as you can see. All right. Any questions? So what I'm going to do now is I'm going to plot the value counts, the count plot of each of these columns. You're going to have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 visuals right now. So it's very easy. You can just use one for loop. You can for loop through the list and then write one line of code to plot the count plot. So for that, what I'm going to do is I'm going to use the for loop for columns in this object list, right? I'm going to give the figure size again just to have some customization. You can do 8, 4, 7, 3. It's your wish. It doesn't have to be perfect. And I'm going to use SNSD bonds count plot. All right. I'm going to give it in an x-axis. You can give it in x-axis or y-axis. It's up to you. I'm going to give the data frames columns. So what it does is first one is going to be senior citizen. So it's going to count plot for senior citizen. Then again, it's going to go to gender. It's going to do a count plot for gender. Again, partner. That's what it's going to do. But I want title for each. So for that, I'm going to do title for column, right? And then obviously PLT dot show. As I mentioned, see, it'll just do the count plot for all the categorical columns. It's very easy, it's very time saving, and you can have a quick understanding of the distribution of data in your categorical columns. Okay. And as you know, there's a huge imbalance in the target variable. It's very biased with no, and we have much less minority class that's for yes. And that's the next thing that we are going to do. They are going to pre-process and do some data model and training. Okay. Now that we are done with EDA, do you have any questions or is it good? Just in case, I'm going to paste my code in the chat box. Okay. Next is data pre-processing. What we are going to do is, as I mentioned, missions don't understand any word strings or characters. It only understands numerical values. So we are going to use the label encoder in order to change all the yeses, nos, no phone service to labels. So it will be like 0, 1, 2, 3, right? No phone service will be 1, no will be 0. So whatever yes will be 2. So it'll all be labels. There won't be any characters when you use label encoder. And for either you can use for if you have like a very less categories, for example, for churn, no and yes. That means you can all obviously use replace function. So what I'm going to do here is I'm going to use replace function on churn, right? df.churn equal to df.churn.replace. We already replaced once before for replacing the space with 0. So I'm going to replace, I'm going to use a dictionary. It's very easy. So we are going to give, if it's no, the key is no, then the value would be 0, right? Comma, and if the key is yes, and the value would be 1. So we are going to use dictionary or else you can use comma, it's up to you. But I just want to cover as much topics as possible in this video. So df.churn.replace, no means 0, yes means 1. All right. I'm going to see how my, see, as I mentioned, no, all the no's became 0 and all the ones became, yes became 1. All right. But for the rest, what I'm going to do is use like label encoder in order to remove all the characters and make it all numerical. And for that, again, I'm going to use the same columns to list like the one I did before. I want to do this for all the columns at once to save some time. You can't do this entirely for each and every column. If you have more than hundreds of columns, it'll not be ideal, right? So instead of, I just want to see columns first, just to see what we are working with. Okay, I'm going to do object columns or columns. Okay. Okay.
Can you show again the no and yes prompt?
Oh, yeah, sure. So whatever value column you're changing, it has to be in the left side of the equal to df.churn.replace. Dictionaries braces is the curly braces. Key colon value, comma key colon value.
Got it. Thank you.
Yeah, no worries. So let me see what we
So
have.
just for my understanding, we're doing all of this because it can happen that you grab a lot of data, but this data is all scrambled. You don't understand what yes or no or 0.15 means. And we're trying just to filter in a way that we can understand as direct output, like 0 or 1 or
No, we can understand all the DSL no or yes means, but the computer, it understand only numerical values, right?
yes, yes,
So
that's
that's
what I
why,
meant.
yeah, it's not up, like it's not for us, it's for the computer to know what yes and no means. And that's why we are changing all the strings to values. That's it.
Correct.
And that's
Okay,
why we are changing no to 0 and yes to 1.
perfect. Thank you.
Yeah, no worries. So this label encoder is very, very cool because the algorithm is already written. But in Python, you just have to reuse the code. You don't even you need to know the math behind it. That's it. What is happening behind it, the logic behind it. But you don't need to do anything. You don't need to do all this replace stuffs, anything like that. So we'll first see what it like. I just want to see the object columns. See, object columns is now a list or array, right? So now what I'm going to do is I'm going to loop through the array, and for each column, I'm going to do a label encoder. That's it. Very simple. Again, for column in this particular object columns, right? So we already imported the library, the dependency, right? On the top, the label encoder. For this, you need to create a object for this class. Okay, that's the always you have to do that. You have to create an object for each class, and that's what we are going to do now. Oh my gosh. Okay, so I'm going to, this is the object, right? But I need a variable that's a object to this class. So I'm going to do like label anything. You can do anything that you can remember in the later part of the code. Label encoder is equal to label encoder class, okay? And what you have to do here is each column, it's going to grab each column and it's going to replace that column with the label encoders. Okay. Oh, columns. This. Okay. My bad. Label encoder dot fit transform. This is a very simple syntax that you have to remember, right? Again, the df dot call. So what it does is, first it loops through this particular list array. It takes gender, right? It creates a object for this class. It does fit transform on gender and replace the gender with a numerical value. That's why we are doing df of call equal to fit transform of df dot of call. Okay, that's it. Very simple. I'm going to call df, and now you can see it's all now numerical values. So you don't have to do anything. It's all you just have to write this one line of code, and the library does everything. The algorithm does everything for you. You can't see any characters or strings over here. It's all numerical. Now the computer can understand and we can train the computer now with this data, right? Uh, okay. We are now on to the exciting part. We are going to split the data into training and test. All right. So for that, as I already mentioned, we already imported this particular train test split library dependency from the scikit-learn's model selection. So again, you have to create a class for the model class for the object for the class, and then you have to give like train data, test data. So X train, X test, Y train, Y test. Okay. So I'm going to write. Okay. So what you are going to do here is for the for splitting the data to training and test mode, like you have to know which one is your target variable, which one is your input variable. So target variable, as I already told you, it's always going to be the churn. It's going to predict if the customer is going to churn or not. That's it. So that's going to be the target variable. And your input variable is everything but the churn. So you have to drop the churn from DF and store it in a variable. And the DF churn should be a variable itself. So X is my input variable. So for that, I'm going to drop my churn. Okay. I don't want to do in place because I'm sending into a new variable. Okay. So I'm going to show you what X looks like. It has all the columns except this churn column. So that's going to be my input variable. Okay. And my Y is going to be only the df dot churn. Okay. So based on this, we are going to split this into training and test samples. So X train, X test, Y train, Y test equal to train test split off. The syntax for this is you have to give the input variable, the one we created, X, then the output variable, the target variable, and you can either give test size or train size. So I always give 80 percentage, 20 percentage. So training would be 80 percentage of my sample input variable and test would be 20%. So test size would be 0.20, zero point 0.2. Okay. And there's one more thing called random state that you have to give. So I'm going to give 42. That means every time you're splitting the data into train and test, it's always going to be reproducible. It's always going to be not random. So it would be always the same data would be trained again and again so that your model won't be, exposed to the unseen data so that you will be able to test it properly without any bias. So that's why we are giving the random state. Okay. Now that we have this, um, my white train is my churn, right? So white train dot value count, as I mentioned, it has a lot of no values more than yes. So the model would be very biased. It won't have much value counts. It won't have much values like for the churn category. So the performance or the accuracy for churn would be very less when compared to zeros performance or score, accuracy score. And for that only we are going to use something called SMOT. All right. So SMOT, full form of the SMOT is synthetic minority oversampling technique. It's a machine learning technique used to handle imbalanced data sets like this, where one class has significantly more examples than the other. And that's the definition for SMOT. So what SMOT does is it'll identify the minority class and it'll upsample or oversample it so that the SMOT result would be both would be the same. So it would it 0 would be 4138 and 1 would also be 4138. It would create like a new synthetic examples by like interpolating the existing ones. It won't like create like duplicate rows. It will like interpolate the existing ones and try to estimate or make some guesses and make these two equal so that the model would be trained in an equal number of churn results. Do you have any questions so far? Uh, okay. So what we are going to do here is we are going to use smote. So I'm going to create an object for this variable of this class. So smote equal to the capital SMOET of, I'm going to use the same random state 42, right? Okay. Now what I'm going to do here is, um, you can only use mode on training data. You cannot use mode on test data. So what I'm going to do here is xtrains mode, comma, ytrain mode equal to the object that we created is mode. So it's mode dot. Here it's going to be not fit dot transform. It's going to be fit resample of the existing ones, xtrain and ytrain. That's it. So now the Smoot's value count, if you look at it, it would both be 4138. As I mentioned before, it did not create any duplicates. It created like estimated or interpolated of the existing values. So now the model won't be biased. You can train the model with equal churn and non-churn training data sets. Okay. Uh, Let me know if I'm going too fast. Okay, so now we are on to the last but one part. So we're going to train the model with the default parameters, and we are going to use cross-val score to determine which model would have like higher accuracy score, performance, and based on that, we'll be able to train the model perfectly. So for that, what I'm going to do is I'm going to create a dictionary of models, right? So what is that is models equal to, and so dictionary is always going to be key and value, right? So I have three models already imported in my dependency. That's decision tree. So decision tree classifier is the class, and I'm going to use the same random state 42. Each model should have a random state, and uh, this classifier's class would have multiple parameters. You can actually modify the parameters to improve the performance, but I'm going to go with the default parameters. I'm not going to do that during this workshop.
Can you
Random forest.
can you just explain again why you chose the random state to be 42? It can be any number, right?
Yeah, it can't be any number. It has to be certain numbers like 10, 42, 33. 42 is like used for reproducibility. So when you're like running this code again and again, the same set of data would be trained by the model. It won't do random training. It won't do take random 80 percentage of the training. It will always be consistent. So that's why I use random state 42.
Is it almost like adding a noise into the data?
Oh no, no, it's not noise. It's yeah, you're telling the model not to do random training sets. Yeah, it always has to be like same set of data that's to be trained. So when you're like rerunning it again and again, it might be anything, right? Out of 100 percentage, it can be any 80 percentage. But this
Huh.
random state for you to make sure that it's always the same 80 percentage is being trained. So when you
Okay,
like rerun the code, it's always going to be like not random. It's always going to be the same set of data that's training the model.
got it.
Yeah.
Thank you.
Yeah, no worries. So again, random state 42. There should be a comma in between. And the one more is XG boost, I guess. Yeah. XG boost, XGB classifier. Right. Now that I have my model items, I'm going to obviously do the for loop, and I'm going to go through this dictionary, and I'm going to get the accuracy of each dictionary, like each model, and see which one should I use the most, like which has the most accuracy. Okay. So for that, what I'm going to do is I'm going to initialize like a dummy dictionary. Initialize dummy dictionary for CVAL score. Right, so I'm going to do like CVAL score, and in the end of the score, it's going to be appended to this dictionary. Okay, CVAL score is equal to dummy, so that's okay. That we are going to reuse later. So for model name, comma model in models dot item, right? So what it does is it's going to models dot items is these three, right? This is models dot items is these three. Model name is this. Model is the value. Key is going to be model name, and the value is going to be the model, right? It's going to loop through this, and uh, what it's going to do is score. I'm going to create an object for the C crossval score that I already imported for my dependency crossval score. What you have to give here is you have to give the model itself. So estimator means the model, right? And next one is X. X and Y means X train smooth and Y train smooth that we just got. right? We already done X and Y. And next is CV. Okay, you don't scoring we need, CV we need. What else? That's enough for this. So CV equal to 5. We are going to do 5 cross folds. So I'll just give you I'll just give you what CVAL score does. I'll just give you an idea. Um, Actually, CVAL score is used to, do 5 trainings at once. Like, 1 second, let me give you the proper score. So, um, it like tries to like estimate a model with like 5 different types of scores. So for the first fold, only the 4 folds would be trained and 1 fold will be validated, and it will be done 5 times. And the mean score of each training would be the result of the CVAL score. And this is actually like repeated 5 times. Like we are using this to do 5-fold cross validation. That means the training set is split into 5 parts, and the model is trained on 4 parts and then validated on the remaining 1 part. And so we get 5 accuracy scores, and then the average of it would be stored over here, the CVAL scores. I hope that's clear. I'm not sure how else to explain this, but that's the meaning of the cross-val score. Okay, so now we have CV is equal to 5 and scoring equal to accuracy. Okay, so now what I'm going to do here is I'm going to show what scores look like, and also I'm going to show what CV scores looks like. Okay, I'm going to store my CV scores with the model name, and the value is going to be the scores. That's it. So this is going to be appended over here. So the key would be model name, that's decision tree, and the scores would be each scores. Okay. And as I mentioned, we have to aggregate or take an average of all 5 scores. So what we're doing over here is I'm going to print, right, the model accuracy score as I'm going to take a average, right? As I mentioned, I'm going to take a mean. For that, np dot mean of these scores that I mentioned. And for this, I want it to be 2 decimal places floating integer type. And this is the result. I'm going to, for readability, what I'm going to do here is print this 50 times. So, it's training the decision tree first. The model score of decision tree, the classifier is 0.78. Model score of random forest is 0.84. And then the model score of XGBoost is 0.83. How this values came is I'm going to show you what CV scores look like. See, since I did 5 cross-val scores, it did train the model 5 times with an unseen data, and the average of these 5 scores is 0.78. Average of these 5 scores for random forest is 0.84. And average of these 5 scores for XGBoost is 0.83. And obviously 0.84 slightly higher than XGBoost. That's for random forest, and that's what we're going to train the model with. You can either go with XGBoost, it's not much of a difference. But I'm just going to, for the sake of this workshop, I'm just going to go with the random forest classifier. Okay. This is how you can like determine the score or which one to go with. You might someone might also do like stratified k-fold. That's one more topic that's like pretty advanced in order to like improve the performance or like to get the proper scores of each of the model. But I'm just going to stick with CV scores, and I used only the random parameter, I mean default parameters. You can fine tune this, do hyperparameter tuning over here, and give different parameters and test which scores are highest. But I'm not going to do this. It's a very beginner friendly class, so I'm not going to go into that. Okay, now that we are going with the model score 84, which is random forest, I'm going to do like model equal to random forest classifier. Again, obviously random state. I'm going to train the model, okay? I'm going to equal to 42. So I'm going to do model dot fit. That's how you train the model. Model dot fit is always going to be the way you train it. What I'm going to do, train it with this, the smart training, okay? The smart we did. Smart, X smart, and Y smart. That's it. And now the model is being trained, okay? And what you're going to do here is you have to do like whitest predicted and then the whitest that is existing. So whitest predicted is based on the model we trained, what prediction we get, and we are going to compare it with the whitest. Existing whitest we already did while we split the data using train test split. But know that that whitest also would have biased, imbalance in the target class, but we cannot do anything. All we can do is go with the cross-val scores with the performance. I know the whitest of the churn value one, that the churn result is going to be very low because we don't have much data that the data has been trained with, or it's going to result out. Oh, value counts. Even though we did train smooth for the training data, the test data is not still imbalanced. That's why we still have like very less one churn category and zero non-churn category. And I know my performance for my one churn is going to be very less, as I mentioned. Okay. So for that, as I mentioned, I'm going to do like white test predicted. That's going to be model dot predict. Okay. And I'm going to do this with X test. So what if the model that I already trained is going to predict my existing test value. And that's my Y test predicted. Okay. And for this, the dependencies that I already imported, right, on the top from scikit-learn metrics, accuracy score, classification report, confusion matrix. That's what we are going to use now in order to like get the accuracy score and how we got the classification report is from. For these two, like what we are going to test this against the accuracy score is whitest predicted with the existing whitest. Okay. So accuracy score of whitest and whitest predicted, as I mentioned. And same way we can do confusion matrix, right? And for that, what I'm going to do is confusion matrix of same whitest and whitest predicted. And I'm going to do the same for classification report. So this is going to give me like the whitest predicted accuracy score with the actual whitest. As I mentioned, the accuracy score does not matter because the model is very biased for the training data set, but for the test data set, but my training data set, I know it's going to be having like 84% based on the cross-val score. The confusion matrix, what this number means is 878 and 219 are the correctly predicted numbers. So 878 times we got the churn result as 0 and that's correct. And 158 times it was wrongly predicted. And for the churn 1, that's being the customers are being churned, my model predicted 219 times that the churn actually occurred, which is correct. And 154 times the prediction was wrong. And it's okay. But my classification report for the precision recall, F1 score, everything, I know, as I mentioned, my zero, like no churn is going to have a pretty good performance or pretty good accuracy score because we did smart or because it has like much higher value for the model to be trained against or tested against. But my number one, like the churn report equal to one, it had only 373 test records. That's why my accuracy is not much. And that's all I had for this workshop. I'm going to give paste my GitHub repository. It has all the code, all the pickle files, all my data sets over there. I'm going to share it in the chat box right about now.
Um, can you give me an overview from where you started from the module accuracy there, all like up to where you are right now?
I'm sorry,
Just to see if I got the understanding.
can you repeat the question? Sorry, I couldn't
Y-
get you.
Sure. Can you go up on your code?
Yep,
Okay, there. The CV scores there that you get for decision tree, random forest, and
yep,
XG boost. Can you go into the lines again and just kind of
of
explain what
course.
you did there? Because I think that's the big
Yeah, yeah,
part.
of course. Yeah, I know I went too fast. I think, yeah. So what I did was I first did a dictionary of my models. Okay. So my models is something that I did, like I initiated. So my dictionary has key and a value. Okay. The key is the name, any name, like you can do DT or something. It's as long as you understand the code, it's good. Dictionary, and I call this dictionary classifier, the dependency that I imported from sklearn, right? And random forest also has the same classifier and XGBoost classifier. So my models items are three. We have three items, key and a value. Okay. So what we have here is we are initializing a dummy dictionary for CVAL scores. Once my scores are calculated, I'm going to append the scores to my existing dictionary. Okay. That's what this is. I'll tell you, I'll come to that. But here, the first line of code, what it does is it's going to loop through my model here, my models items. So model name, comma model in models dot items. That is model name is dictionary. That will be the first loop and my model. Okay. What it does is the scores equal to cross-val scores. You should always create an object for a class. As I mentioned, I created a variable for a cross-val score. So the syntax for cross-val score is first every time it's going to be an estimator, which is the model, right? That is the model from the model for loop. Okay, so it's going to get the relation tree classifier for the first one. And the x and y value are the next in the syntax. So I'm going to use the x trains mode and y trains mode. It's going to train the model with the existing default parameters. CV equal to 5 means what it does is it's going to train this model 5 times. Okay. What it does is it's going to split the training datasets into 5 parts. The model will be trained on 4 parts and validated on the remaining 1 part. So it will be done 5 times again and again. The data set will be split for like five into 5 parts, and the model will be trained with 4 parts of the unseen data and validate on the remaining 1 part. So every time this happens, the model will be trained with the unseen data so that when you get these scores, this is the CV equal to 1, this is CV equal to 2, CV equal to 3, CV equal to 4, and CV equal to 5. What I did was I did average of all these 5, and then I use this to print my model accuracy score. That's the numpy's mean function of these 5 scores, and I rounded it to 2 decimal places. That's why it has only 0.782 decimal places, right? And this line of code, what it does is the CV score of it takes the model name from the loop equal to scores. So it will score like it will store key as the model name and values as all the 5 scores. You got it? If you want me to explain again, I can explain. We have time till 8 o'clock. That's okay. And just
Uh,
print 50 times of this is just for readability. It just prints this. That's about it.
Yes, but forgive me for my question, but the model accuracy there, what does it represent in that sense? It represents that
What it represents
78%
is
of
you go
my
with the best accuracy model, right? So every time the training data is done, it'll give you like a score, accuracy score. It'll be done 5 times, but you have to know some might so like some part of the training data would be not much. Like it would have majority of non-churn than churn. So in that case, the model accuracy here is 0.68, right? So it means it did not have much values to predict. So that's why
uh-huh.
it's low score. But the next CV cross validation would be of a different unseen data of the model that will have a different score. And the other one would have different data that the model is being trained on. That happens 5 times. You can even give 10 times. If I give 10, my score would be very different. It'll have like 10 scores and I will have average of the 10 scores. You can give any CVs. Wait 1 second. See, Decision tree itself have 10 CVs, 10 values. Each one have different accuracy score, but at the end, the CV score is determined by averaging all 10 accuracy. I would suggest like maybe going through a couple of YouTube videos. I didn't get it first time as well, to be honest, but maybe this is like this is a form of like predicting sorry, which scores are like which performance of the model is more than the other so that you can go with the best model in order to train your uh, train data. Okay, train your model for the training data.
But in that case, you're training the model with three different accuracy models to see which one performs best.
Exactly.
Oh, I see. Okay.
Yeah, these are
That
all
makes
different
sense.
models, right? But I'm selecting the best of these three. We have like a lot more models, like linear regression model,
Yes,
logistic
okay, now I
regression.
understand. Yes, thank you.
Oh, yeah, maybe 1 second. Let me fix my code a little bit. 1 second. So first it's training using Bayesian tree classifier. So the model accuracy is 0.78. Next it's training using random forest. So it's going to loop again. It's going to go to my second model item and it's still training and it's to 85, right?
Hmm.
And the third one, I'm training using XGBoost. That's the third item in my models. And the model accuracy score is average of these 10. That's this line of code. This
I
is
see.
just for appending to my dictionary, This is the
Yeah.
dummy dictionary. This is empty dictionary initialized
Hmm.
and append scores to the empty dictionary. So this is only for populating this. You don't even need this. This is just to show you all those CVAL folds that happened, all the 10 folds that happened. But this is the printed one over here.
I see. So when you go, after you take the CV scores and then you check which one is the highest, that's what you're doing, right?
Yeah, I'm
You're,
taking the mean of all the CV scores, and that's
yes.
how I get the result of which one is the highest or best performing model of the three.
So then when you take the model, okay, so if you scroll down a little bit more,
Yes. That's why
okay,
I took
so
random forest.
yes, you took random forest because that was the highest. Random forest classifier, then you apply the 42 there just to be random in that sense. The
Just
model
to
fit.
So this is how you train the model. This is like creating a class for the
Okay.
model, object for the class. That's it. You're just creating a variable for this class. You don't even need, I'm going to remove this for EW. That's it. This is the class and this is an object. And this algorithm would be saved here. And that's why I'm using this variable dot fit. You can't use like this random forest classifier dot fit. You're storing all the classes objects in one variable, and I'm using that variable. And the syntax for fitting the model or training the model is model.fit xtrain and ytrain. Instead of that, I use xtrain smooth and ytrain smooth because I already did the class balancing for the target variable. That's it.
Hmm.
And I'm just
Yeah.
using, then the next one, always do model.fit, model.predict. That's it. That's what I'm doing here. Model.predict. I'm predicting it with the existing test that I already did over here when I split it. See? So with the X train, you're training the data and the result would be the churn. That's the Y train. X test would be the 20% sample, right? That
Yes.
you have not trained before.
Yes.
That test data, you're going to use the same model that you trained. You're going to do a prediction based on the model and you're comparing it with this white test. That's why
Oh,
it's
I
white.
see.
Yes,
You're taking
white.
20% of your data to be a test fit for the model prediction that you just find out. So
Yes,
that's why
because
you
my model
use
hasn't seen that data
X
before,
test.
right? So it's a fresh data that I want to see the accuracy, how well my model is performing. Or else you
Okay.
will overtrain the model. You can't give 100% of your data as a train data because that means your model would know everything, right? If you're
Yes,
learning like 10 questions for an exam, if they're asking only those 10 questions, you would pass for sure.
I
But
see.
uh, if you're given like two questions that you are not knowing based on those 10 questions, that means you are using that trained brain in order to solve the extra two questions you haven't seen before. And that's the Y test.
I see.
I know it's a pretty big topic for a beginner class, but if you take your time in order to do one project like this, you have a lot more data sets in Kaggle, like heart disease prediction, autism prediction. You can use actually the same code that I used, like the functions and the for loops to do EDA. You can use the same code to quickly like reuse the code. You're automatically going to use the code by hearted code after the fourth project or fifth project. So these are like something that you can reuse for any project, and you can put that in your resume because it has covered almost all topics that the recruiters are going to ask for.
Okay. So if you go at the end, then
Yeah.
after you predicted your model, you use that specific model there. Um, what do you do? Okay, so you get what is the white test value counts there?
Uh, I haven't. So my model has seen everything now, right? So once the new data comes in, once you are like giving like very like new data that the model hasn't seen before, you have to do the label encoder one more time to convert to numerical, and you just
Yes,
have to do model.predict on that new value. That's it. You don't have to train it again. You have to do
yes,
model.predict. I don't have that in my hand because I thought it would be like we would be going past 8 o'clock. But
I
that's
see.
what you're going to do. Like,
No,
you're
but
going to
I
re-
understand. What I'm saying is that line white test dot values dot counts that you have churn. What is actually represent the zero and one
oh,
there?
see, the smart we did, right? The 4138, 4138, smart we did for the train data. Wait. See, for the value white train, the value count was once 4138191496. Then we did smart in order to balance it, and we got the 4138, right? For each. The smart would actually create upsample the minority class, the one that is like not much
Yes,
available. We did this only for the train data, but the test data still has biased data.
Okay.
So that's why the accuracy score for the churn one would always be less because I we can't do anything. We can't do smooth on white test. You can't do smooth and make it both 1036, right?
It,
And that since my churn zero has more number of values, right, in my test, that's why my prediction for precision for my zero is also greater, 85 percentage. But I don't
so
have much value. I have only 373 for churn one
so
test.
just to make sure, the churn that you're specifying there is like customer leaving the service, right?
Churn one is customer leaving, churn zero is customer using the service.
Yes. So in that sense, after you ran test, um, your test matrix there, because that
Mhm.
was the 20% out of the whole
Yes.
sample, right?
Yeah.
What does it represent? It's saying that your customers are still within your service and just like one third are leaving. That's what it actually means.
Uh, this is the existing data from Kaggle, right? We have not trained, this is not like a new data. Once a new data comes, you're right, you're actually right. But we don't care about the white test. We don't care about the 20% because it's already biased. We can't do anything about it. They've
Yes,
already
I
trained it to
understand,
it.
but just the representation, that's what it represents.
Yes, you're right.
Okay, because now what you need to do is what you did is you figure out what is the train and what is the process that you're going to use to model the new data that you're going to get. So let's say that you get 1,000 points tomorrow. You can take those 1,000 new data points and then use your prediction data to actually tell you which customers are willing to stay and which customers are actually trying to leave.
Yes. I'm not going to use my prediction. I'm going to use my fitted model, not the predicted
Yeah,
model.
yes, your fitted model. Yes.
Yes, you're right. That
Okay, I
way, we
see.
will be able to predict the incoming data, customers' data they're going to churn or not, and that way we can ask the team or business, finance or marketing team can reach out to them and make necessary action, not for them to churn. Maybe give
Uh-huh.
them some offers or something
I
like that.
see. So in the last part there that you have accuracy, confusion matrix, and classification report, I don't have much of that background, but I'm assuming it is like these are numbers that represent how good your classification was.
Exactly. How good my model was.
Uh-huh.
But I would always go with the CVAL score because of the mode I used. My white test won't have much accuracy because of the bias, right? So,
Okay.
according to me, this is my model score, 85 percentage, because
So
this
85 you have a percentage of 85% to be right about your prediction about your services and if your customer is gonna keep staying with you.
exactly.
Uh-huh, I see. Okay.
It's not much, but if you're doing parameter tuning, you can even achieve 95 plus accuracy score, which is really good. You can't, you in the place where you use random state 42, there are like lot of parameters that you can actually use for relation tree. I don't have it in my hand, but there are like a lot of parameters that you can tune and make changes, make trial and error iterations, and improve the model score. It's not like you can't do once and then stop. You have to improve the model score. You can test out new parameters, and that's how you can achieve nine. I have even achieved 99 accuracy score before,
Wow.
but
But
it
but
takes
then
time.
but then question for you then. Okay. This is a simple almost like a simple data that you
Mhm.
have, right?
Yes.
When you receive a new data, this new data is from new customers that are not represented on your previous
Yes.
data, or these are actually you can have the same customers within this new data.
It's unseen data, new customers,
Okay,
new
that's going to
parameters.
be completely new customers in that sense.
So, what you can do here is the model that you train here, you can import the model itself, and then reuse the model again and again to fine tune your model. Okay. As you get more data in the future, you can retrain your model with more data. One day you'll have 100,000 data, and another day you'll have 1 million data. 1 million data you can train. That's what ChatGPT does. It keeps on training its model to improve its prediction or improve its suggestions or language models in order to like communicate with the humans.
Yes. Okay, so let's put this in an example, just see if I understand this right.
Mhm.
So let's say I have a list of 100 clients.
Mhm.
Okay. I take this list, but I have all of these 100 clients. This is all that I have. I'm not gonna get new ones in that sense. I want to use those 100 clients to understand if they want to stay or if they want to go.
Mhm.
What would be the best approach? Would be to actually, out of those 100, take randomly like 70 out of those. So I
Mhm.
keep 30 out. And
Yep.
out of those 70, I do this train model and I figure out of those 70, what is the percentage that want to stay and what is the percentage that want to go. And then I take the rest, the other 30 that I did not use, and I use those 30 to check.
Yes. Yeah. And then you can so the 30 that you already know and the 30 that you're going to use to predict, you have to compare those two. You know what those 30 are. You know what the percentage of churn are for those 30 percentage. And you let your model predict based on the 70 percentage. You have to compare those two end result to see the accuracy score. How well this matches your existing data. Because you already have the 30% in hand, you can already see the data, right? You can test manually and test it with the fitted model, what it predicts, and then make comparison. I always go with higher percentage of trained data and less percentage of test data because the more data you have to train, the more performance your model will have.
Uh-huh.
I hope I answered your question.
I think you did. It's just that for me, there's a few, how can I say this, but like there's some structures that are brand new to me in that sense that I'm just
I
trying
totally understand.
to
Yeah.
make sense for myself. Like
Mm-hmm.
if I have 100 clients in that sense, and I understand that you're saying that if I take 70 just to make my train data and then use the other 30, I already have those 30. Those are not new clients. So is
Not
it
new
going to be
clients for your
some,
model, right? You have your model haven't seen those 30, but you know those 30. You have to do your manual analysis and then compare with the fitted model. That's why you have when you do the train test split, you have the y test and you don't use the y test anywhere, right?
yes.
You model, you do the prediction on the X test and you take the Y test predicted and you compare it with the Y test that you already used you already got when you split the data using train test model. You're not using the Y test anywhere here. That's the 30% that you're mentioning.
Uh-huh.
Okay, you got it now. So model.predict of X test is the 70% and Y test predicted is the prediction that your model already trained with the 70% is predicting you. And the y test is already you have over here. So you can actually compare it. That's why the confusion matrix comes into place. The confusion matrix will tell you where the model went wrong. You know the customer churned for that particular wait, let me give you one example. Sorry. I know it's getting late, but the DF, where is the DF? Wait, this one, right? You know this particular customer did not churn. Okay. That might be one of your 30 percentage that you did not give into the fitting of the model.
Oh, I see.
So if you give the same data to your model, right,
Yes.
you have to see if the model is predicting no or yes.
No, I see what you're saying. Okay, I got it. What I was referring to is I have 100 clients that I do not know if that table churn, that column churn is yes or no in that sense. I'm just saying that I have only 100 clients. I want to
Okay.
predict 70 out of them and then use 30 for, for trial.
You have to have churn in that case as well, right? In order
Yes,
to,
you
yes.
would require somehow a way to actually predict if it is churn or not.
If you already have a model that's been trained before, then the incoming model does not need to have the churn column. You just need to use the already fitted model with your historical data and use this 100 as your test data itself. You can use this to predict, only predict, not to train anything.
I
You
got
can
it.
use
Okay.
entire 100 to predict.
This
Yeah.
is good. Thank you. I really appreciate the
Of
you
course, yeah,
explaining.
no worries. Thank you for staying till the end of the workshop. I actually pasted the GitHub link that has all the code that I did today, as well as more.